All right, we've got a couple more problems to do, and this one we're looking to find how long it will take. So we're looking to find the time it takes. Now distance equals rate times time. So time equals distance divided by rate. So again, I'm looking for the distance the time to travel from Earth to Mars. Now I know the rate of the speed. I'm using the rate of travel for the Apollo mission, which we discovered was just 2.2 kilometers per second. Okay, but I don't know the distance. I need to know the distance from the Earth to Mars. I know the distance from Earth to the Sun, and I know the distance from Mars to the Sun, but I've got to figure out the distance from Earth to Mars. That's when I asked you a previous question. Okay, use information from the table to determine how far apart Mars and Earth are on average. What we do know from our table is the distance from Earth to the Sun. And doing a little bit of work, I can tell it's 1.5 times 10 to the 8th kilometers. And then the different distance from Mars to the Sun is about 2.3 times 10 to the 8th kilometers. So I can tell how far apart they are, knowing what's the difference between their distance from the Sun. Again, this is an average, so it's just a reminder that this is just an average distance, since planets, when they go around their orbit, sometimes they're further away, sometimes they're closer. But on average, we're this far apart from the Sun. So if I subtract minus 1.5, you can find the distance between the two objects. So subtracting a little bit, carry the 1. 13 minus 5 is 8. The 1's cancel out. Now the 10 to the 8ths don't affect each other. All we're doing is subtracting the digits in the very front. This 10 to the 8th just represents all the zeros at the end of this number that we wouldn't worry about. We just have 0 minus 0. Nothing there would change. So I've got 0.8 times 10 to the 8th. I've got to move that decimal. So I've got 8.0, or just 8, times 10 to the what? So we've got to think. Okay, I moved this decimal to make my number bigger, so I'm going to make my exponent smaller. So 80 million kilometers apart. Now we can use that number to figure out how long it would take. Well, time is distance divided by rate. And I'm thinking this is going to take us a while. It might be helpful to think of this as 10 to the 0, just so we can see that there is no change in the exponent here. Going to need some room. So I have to take 8 divided by 2.2. 8 divided by 2.2. So I know 8 divided by 2 is 4. And I've increased the number on bottom a little bit. So that means if I increase the number I divide by, the number I get as a result will be a little bit smaller. So it's going to be smaller than 4. It ends up being about 3.6. And then there is no change. This is 3.6 times 10 to the 7th. Oh, forgot my seconds. The kilometers divide out. I'm left with seconds. It is this many seconds. That's 36 million seconds. Okay, if you're curious, I'll leave that to you to figure out how many days, weeks, months, or maybe years that is. It's going to be quite a while. So good luck with that. But now we know how long it takes to get from Earth to Mars. You can do the same thing for Earth to Jupiter and then Earth to Pluto, and see how we might want to be investing in some better propulsion devices if we're ever going to actually make it this far. So good luck working with scientific notation. Do your best.